Here's example 6 with integration by substitution. So it's another definite integral, so we do want to change those limits, be careful about that. So first we want to look for a function and its the derivative, or a function and a constant multiple of its derivative, and if that doesn't work then we'll try and look for the inside guy. And either of those are actually going to work in this case. So let's let u be, so what kind of function do we see? Well, here's an e being raised to x squared plus 5x minus 6. Here's a 2x plus 5. So what if we let u be x squared plus 5x minus 6? Then what's du going to be? Du is going to be 2x plus 5. That whole thing is dx, has a dx on it. Okay, so that's great. You know, that's exactly what we have in here. So let's rewrite this so it's a little more clear. So this is an integral from 1 to 3 of e to the x squared plus 5x minus 6, and then times 2x plus 5 dx. Okay. So again, if this function and its derivative didn't jump out at you, then you could say, okay, let me try to let u be the inside guy. And what's the inside guy? Well, here, x squared plus 5x minus 6, that's inside of this exponentiation here. So this is e to a function. This function is the inside guy, so let u be that. Okay, so two different ways to think about it, both work. Okay, so u is x squared plus 5x minus 6, so this is just e to the u, right? This is e to the u. And then 2x plus 5 dx, that is exactly du. That's exactly what we have. That's wonderful. Okay, so now the integral becomes the integral of e to the u du. Okay, but what happens with the limits? So we got to be very careful with those limits. Okay. So x is what goes from 1 to 3. X goes from 1 to 3. So we have to set up our little chart. So let's make that real quick. So x goes from 1 to 3. So now we have to figure out, okay, what does u go from and to? Well, when x is 1, u is 1 squared plus 5 times 1 minus 6, right? So we're getting that from here. U is x squared plus 5x minus 6. So if x is 1, then u is 1 squared plus 5 times 1 minus 6. 1 squared is 1, plus 5 times 1 is 1 plus 5 is 6, minus 6 is 0. If x is 3, then we have 3 squared plus 5 times 3 minus 6. So 3 squared plus 5 times 3 minus 6. So 3 squared is 9, 5 times 3 is 15, 9 plus 15 is 24, minus 6 is 18. Okay, so u goes from 0 to 18. So the limits of integration here are 0 to 18. Okay, and this is incredibly straightforward, right? If we integrate e to the u, we're just going to get e to the u evaluated from 0 to 18, right? So this is much more straightforward than this. If we look at this, it's not too bad, but it is kind of messy. We have the e is the x squared to 5x minus 6, 2x plus 5. So it's just kind of a lot happening. And when we make this substitution, it ends up being really simple. We're just integrating e to the u from a number to another number. And also, since we change these limits now, we don't have to worry about x anymore. Just completely forget about x. Do everything in terms of e's and u's, everything in terms of u now. So let's come down here. So this is e to the u from 0 to 18, so that's e to the 18th minus e to the 0. And remember, e to the 0 is just 1. So this is e to the 18th minus 1. Okay. So that's example 6 with integration by substitution. So kind of complicated looking integral. Just make this substitution. It ends up being not too bad at all. So just integrate e to the u from 0 to 18. And integrate e to the u, you just get e to the u. Evaluate from 0 to 18, so evaluate at the top minus evaluate at the bottom. E to the 18th minus 1 is our final answer for example 6.